Valence bond theory. The basic principles of valence bond theory. A covalent bond forms when the orbitals of two atoms overlap and a pair of electrons occupy the overlapping region. The space formed by the overlapping orbitals can accommodate a maximum of two electrons, and these electrons must have opposite spins. The greater the overlap, the stronger the bond will be formed. Now, the extent of orbital overlap depends on orbital shape and direction. Now, here in this slide, you can see example of hydrogen molecule. How hydrogen molecule is formed? When two hydrogen atoms, their atomic orbitals overlap to form a hydrogen molecule. Now, in these two atoms of hydrogen, you can see there are the hydrogen atom, it has one electron in 1s orbital. Similarly, another hydrogen atom, that too also it has one electron in 1s atomic orbital. Now, these two s orbitals of two hydrogen atoms, they overlap to form a molecular orbital. A covalent bond results from the overlap of orbitals from the two atoms. Now, the shared space is occupied by two electrons. In this diagram, you can see the center space which is shared. We can say this space is shared. Here you can see the two electrons, they occupy this space, and that these electrons, they should have opposite spins. Now, here you can see the example of hydrogen fluoride molecule. In hydrogen fluoride molecule, one hydrogen atom and another fluorine atom, they combine to form a hydrogen fluoride molecule. In hydrogen, there is only one electron in 1s orbital. In fluorine, the p orbital, which is having unpaired electron, that will combine with 1s orbital of hydrogen to form a overlap between s orbital and p orbital. In second example, we can see the formation of a fluorine molecule. Here you can see the orbital overlapping is between the two p orbitals of two fluorine atoms. Valence bond theory and orbital hybridization. The orbitals that form when bonding occurs are different from the atomic orbitals in the isolated atoms. If no change occurred, we could not account for the molecular shapes that are observed. Atomic orbitals mix or hybridize when bonding occurs to form hybrid orbitals. The spatial orientation of these hybrid orbitals correspond with the observed molecular shapes. Features of hybrid orbitals. The number of hybrid orbitals formed equals the number of atomic orbitals mixed. The type of hybrid orbitals formed varies with the types of atomic orbitals mixed. The shape and orientation of a hybrid orbital maximizes overlap with the other atom in the bond.